This is lecture number 3. We're talking in this lecture about an overview of the Arduino. This is our second part of the overview of the Arduino. So here we're going to be looking at a lot of the software type issues. So in this lecture, we're going to look at, first of all, the programming the IDE, the Integrated Development Environment, and then we're going to look briefly at serial communications. That's a topic that's really important in terms of being able to communicate using a computer. There's also another way of communicating with a computer that uses a software platform very similar to the Arduino. It runs on the computer and it interfaces with the Arduino. It's called processing. I'm not going to get into that, but that is a very useful tool as well. So the Arduino IDE is based on what is called the wiring platform, which is based on C or C++. So the Arduino IDE is, again, just like C is based on functions, right? In a standard C program, you have your main function is required in every C program. In Arduino, the main function is not required. Instead, we have two other functions that are required. One is called a setup, and the other is called a loop command. Both of them are void, that is, they return nothing, but they're required. So otherwise, you can do includes and defines just like as in C. You can do functions, subroutines, all those kinds of things you can define within this. So I'm assuming that in this class you have a working knowledge of C. Okay, I'm going to just assume that. So I'm not going to cover C programming. I'm going to assume that you have the basic background in that. But here is a book called C Primer Plus, and guess what? It's free. Yay, free! It's hard to beat the price like that, and it's an excellent resource. So you can download it from the website, this website, and it's free. It's like 800 pages, so you probably don't want to print it out, but it gives you the basics of programming in C. So you can use it to refresh your knowledge of the C language, to learn new things about the C language. But so C is an important part of, or the whole structure of the C language is an important part of programming in Arduino, but it's not the Arduino is not programmed in C. It's programmed actually in its own IDE. But it's similar to C. So in terms of the looping structure and things like that, it's very similar. So here's the simplest program in the Arduino. So it just has the two functions, setup and loop. And here we're just not doing anything in those functions. So this is the do nothing program, but it compiles without error. If you don't have these two functions, you will get an error. So this is the simplest function that will compile without an error. So, and sometimes actually it's helpful to actually have this program ready to go in your IDE. So in your IDE you can have several different programs open, their windows open. And it's helpful sometimes to have this program ready to load into memory, so that way if you're working with something and you want to just stop the process, instead of unplugging your Arduino, you can actually just run this program and it shuts everything down, no inputs and no outputs. And so it's helpful to actually have this program ready to go. So if you go to the Arduino site, arduino.cc, one of the links in one of the tabs is called reference, and this brings up the language reference. So you can go there and you can see all the different functions and what they mean. You can get example code. You can see exactly how a particular function is used. Is that function used on integers or is it used on floating point? All those kinds of things, the information is given. So I recommend that you have ready access to this page. There's also a handout that will be made available that has all of the function details, so you can have it as a hard copy. So you don't necessarily have to have all of these access to the website in order to use the information. Okay, so I'm going to now cover briefly all the basic functions of the Arduino IDE. So I'm going to go very briefly through this and just kind of lay it all out just to kind of give you an idea of what's available. Again, it's not like C because there are certain things associated with the Arduino IDE that you don't have with standard C. Okay, so in particular, since the Arduino is intended to be used as a microcontroller, then that means it's intended to have digital inputs, it's intended to have digital outputs, and those things are just not standard parts of C. So usually, in order to get any kinds of digital input or output or analog input or output, you usually have to have a special other hardware that goes with your computer and an associated library for that. So here we're just not going to do that. It's built into the operating system. So here right from the start we see that in terms of digital constants, here are predefined constants, high and low, which obviously is high voltage or low voltage. So if you want to set a digital bit high, then you write the value high, or if you want it low, you set it low. There are also the values true and false that are defined. So high or low, true or false. These are standard predefined constants. Here are some other constants associated with the general purpose input-output ports, input, output, and input pull-up. And so if you want to set up a digital signal, one of your GPIO, general purpose input-output pins, to be a digital input, then you can use that. If you want it to be a digital output, you can use that. If you want it to be a digital input with a pull-up resistor inserted. So when we talk about interfacing, we're going to talk about what the value of a pull-up resistor is, and when would you want to use one, when would you not want to use one, and so forth. So that's helpful. Pull-up input, pull-up. Okay, so those are the standard. Those are standard predefined constants. And in terms of defining constants that you want to use, there are a number of formats that can be used. So you can have an integer formats. For example, I can define something as a binary. So this is a binary, and if I define a number to be binary, then I get 8 bits. Okay, and so I can define all those bits. So binary is one way of defining a constant. I can define it as an integer. So notice here I have a negative sign. I can define it as an integer can be positive or negative. Here I can have other things that you add onto the constants. So U stands for unsigned, and L, that means there is no sign. That means it's a positive constant. And L means long. So I can have a long integer. Okay, well, we'll talk about a little bit about that later. I can define things as a hexadecimal number, or I can define it, if I set a 0 out in front, I can define it as an octal number. We won't be using much in the way of octal here, but in some areas it's very desirable to program in octal. So octal has some advantages that hexadecimal has. It's base 8 versus base 16, but we won't be using octal really very much. Float, you can define a floating point, so minus 1.2. So you need to have a decimal point in order for a float to be defined. If you don't put in a decimal point, so for example, if you have the number 12, you have to put in 12 dot or 12.0, because if you don't put in that decimal point, it's going to assume that it's an integer, and it's going to treat it like an integer. I can define it in exponential notation. So this is an example. So I can use either little e or big E. So this is 62 times 10 to the minus 62 times 10 to the minus 12 is what this number. So so I can define numeric constants, either integer or floating point. Okay, now these are all the data types. So here what we just talked about were constants that can be defined. Here are all the different types of data that can be defined. Okay, and so this table actually has quite a bit of information associated with it. You want to might want to make note of what some of these things mean on here. Okay, so for example, the integer constant data type generally is 16 bits. So when you define an integer, you're defining it as 16 bits. And it's signed, so that means it can be positive or negative. Okay, the C here means there's a conversion function that will allow you to convert from, for example, a floating point number to an integer. Okay, so if you do that conversion, generally it will truncate that number and ignore. It won't round, it'll truncate, which means it just chops off whatever decimal places there are. So you need to keep that in mind. So each of these data types that has a C means there's a conversion function so I can do int of something and it will convert it to that number to an integer. Okay, whereas unsigned int does not have a conversion function. It also uses 16 bits and it is unsigned, which means it only considers positive numbers. So if you look at the range, since you only have 16 bits, you only get certain numerical values available. So basically, these two, int and unsigned int, have the same number of bits, which means you get the same number of values. But if it's unsigned, that means you're only considering positive, which means you can get a higher positive number using unsigned than you can get with signed. So the word data type is very similar to the unsigned int. It is 16 bits, it is also unsigned, and there is a conversion. So notice there is no conversion for unsigned int, but there is a conversion for word. And otherwise, you can go through and show that the unsigned int and the word basically are the same data type. And the Arduino IDE treats them the same. So even though there isn't a conversion function for this, there is a conversion function for this, and these are basically identical. And actually, a number of these data types map to one another. So even though it's a defined specific data type, that doesn't mean it's different from another. There may be another data type for which it is identical. So keep that in mind. There is a short, which again is 16-bit, but it's signed. You can have a long, so like a long int. So this is a long integer, 32 bits, okay, as opposed to 16 bits. And it's signed, and you can get an unsigned long, which gives you a really, really long number. So but here there's a conversion, here there's not a conversion. So we can talk about bytes and unsigned characters and characters. If you define something as a character, you need to define it in single quotes. If you define something as a string, you need to put double quotes. Okay, so that's what that means. For these data types, these are all basically types of arrays. And so there is a command called sizeOf that will return the size of that array. So if you happen to define, for example, a string, and the string has so many different, for example, characters, you can use sizeOf to tell you how many characters are in that string. Okay, so or in that array. So that is a helpful thing. So we have double and float. Again, both of these are 32-bit signed. This one has a conversion function. This one does not, and so forth. So there are a number of things. Boolean is interesting in that it actually only considers 1 bit, but it takes up 8 bits. Okay, so it's a little bit different. So it's either a high or low, or a true or false, but it really only contains 1 bit of data, but it uses up 8 bits. So just to explain what that's all about. So these are all the data types available in the Arduino IDE. Some of these are a little bit different. Notice that here I have string as a different color, because this is a very different kind of data type. It's actually an object. It's not really just a variable type. It's actually an object, and so this carries over from the C++ arena, and so it offers some powerful capabilities, but it's a little different. Similarly with array, it's a little bit different. So, and the number of bits, for example, here that's required. This takes up 8 bits per character, and it has in general n characters. This has 8 bits and the number of elements. Okay, the number of elements. The string, I haven't been able to find out any information about how much data it takes up. It's similar to the little string, so this is capital string, this is little string, but I haven't been able to find out any information about how much data it actually takes up. And also, these guys are signed, and I'm not even sure exactly what that means, that they're signed. But anyway, so these are the data types that we have to work with. So one of the important aspects of the Arduino is that we have input-output functions. We can input or output data through the Arduino, and here are the input-output functions. We have a bunch of digital input and output functions, and we have a few analog input and output functions. If you use a different kind of Arduino than an Arduino Uno, for example, if you use the Arduino DUE, it looks like D-U-E, it's called DUE. If you use an Arduino DUE, you actually have additional analog functions. But these are the main ones that we'll be using. These are the ones that we'll be using. So there is a pin mode, which is used to determine what a pin will be used for. So we have a general input-output pin. Pin mode sets that pin to be a certain thing. Okay, so notice that this works with the digital pins 0 through 13 and the analog pins 0 through 5. Okay, so it works with all of the input-output pins, pin mode. Okay, and you can set that pin either to be an input, an output, or an input with a pull-up. So that's what we talked about that a little bit. And notice that I can use that even with the analog pins. I can set the analog pins up to be input or output, or input with a pull-up resistor. So that's the digital. That's the pin mode. Pin mode allows us to set up a pin to be an input or output. And within a program, you can change it from input to output. Now, if you make that change, you do probably want to allow a little bit of time to make sure that change happens before you start using it. So if you're using it as a digital input and you switch to a digital output, you probably want to allow just a little bit of time to make sure. And I'm not exactly sure how much time, but probably allow a little bit of time. Digital write. Digital write. So here I can actually output a high or a low value for any of these pins. Okay, so it works with all of these pins. So if I want to use it for analog outputs, I would specify that as A0. So that's digital write. Digital read, again, when I read, I will either get a high or a low. And again, I can use any of the digital pins or analog pins. Tone. The tone function can be used with any digital pin or any analog pin. And basically, what you set is you set the tone. You can give it a frequency, which corresponds to a pitch, and it will generate a square wave with 50% duty cycle at that frequency. So that's basically this is. So you can think of this function as a square wave generator, where you can determine the frequency of that square wave. And again, you can put it on any of these signals. So no tone basically shuts off the tone. So these two go together. So if you want to play a song, for example, you would set the tone. If let's say you have a speaker hooked up to one of the pins, or a buzzer, you can hook up. You can set the tone. Then if you want to change notes, you have to do no tone and then switch to a new tone, and so forth. I can also do a pulse in command, which will basically read in. If you're expecting a pulse, what pulse in does is it measures the length of that pulse. How long is that pulse? So and again, I can use it on any of these pins, and it can be used again to measure the duration of a pulse that's coming in. So, for example, if you have, let's say you have a little toy car race, and you've got a ramp that your toy cars are running down, and you have, let's say, some kind of photo detector at the starting line, and you have a photo detector at the finish line. So the photo detector at the starting line basically would, for example, turn your pulse on, and the photo detector at the finish line would turn your pulse off, and then you could see how fast the race went. So that would be an example of of the use of pulse in. So if you had a pair of photo detectors both at the starting and at the finishing for each car, you could keep track of the race times for each of the vehicles. So we also have analog functions. Analog reference allows you to use a different reference. So the standard, if you do nothing with the analog reference, the standard is 0 to 5 volts. But there are reasons for using other voltage references, but the standard is from 0 to 5 volts. You can't ever have an analog reference greater than 5 volts, but you could have an analog reference less than 5 volts. So there are ways to set up 3.3 volts or 1.1 volt. Those are options as well when you use the analog reference. So I doubt that we'll ever actually use that, but it's available if we needed it. So analog read works for analog channels 0 to 5. Analog write works for analog channels 0 to 5. Analog read will read in a voltage from 0 to 5 volts and return a value between basically a 10-bit value from 0 to 1024, 1023. And so it'll return a value like that. Okay, so so that's what the analog read does. The analog write will take an 8-bit number. So this is a 10-bit analog thing. This is a 8-bit analog thing. And basically what this will do is it'll take an 8-bit number and it'll give you an output signal that basically is a 500 hertz signal, square wave, with a duty cycle is dependent upon what you write. If you write a 0, you'll get a 0 duty cycle. If you give 255, then you will basically have constant on duty cycle. So that's what the analog write does. It gives you a pulse width modulated signal. We talked a little bit about pulse width modulation and how that can simulate an analog signal. Not really an analog signal, it's digital, but in some applications it can be used like an analog signal. Interrupts. Interrupts are important things. Basically, what an interrupt allows is it allows you to have your program running, and your program can be doing something, and when an event occurs, basically it stops your program. It goes and does something else real quick, and then it comes back and resumes the program. So it basically allows you to interrupt for briefly what your process is doing. And so this is very handy in a number of applications. And so that's the interrupts. So we can attach an interrupt or detach an interrupt. This basically sets up if you have an interrupt, it tells you what function. So when there's an interrupt, you need to go to what's called an interrupt service routine. It tells you what that service routine is, where it is. Okay, so you can attach an interrupt to a specific pin, and that tells it to go to a certain function. And then you can also detach it. So you have a particular function that's going. Perhaps at some point your function is pretty complex. You want to for a while you want to use one service routine when you get an interrupt, and then later on you may want to use a separate interrupt service routine. a different one. And so you can attach this one, and then when you're done with it, you detach and attach the other one. And so you can do that kind of stuff. This basically turns the interrupts on, allows the interrupts to happen. This basically blocks the interrupts from occurring. So that even if that pin goes, so even though you may have an interrupt service routine defined, what this basically does is it stops the process from being interrupted. Okay, and that can be very helpful if you have a sizable interrupt service routine and you get a second interrupt coming in. It doesn't interrupt what you've already interrupted. So those kinds of things can be handy. Arduino IDE can do certain things with bits and bytes. So for example, if you have a 16-bit thing, you can take 8 bits, which is a byte, and you can look at the low byte, or you can work with the high byte. Okay, so you can grab the low byte or grab the high byte of a 16-bit thing. You can read bits, you can write bits, you can set bits, you can clear bits, and you can just, so anyway, a number of functions that work just with bits and bytes, which is a little bit different than what you get with C. C doesn't deal with things that specifically because, again, if you're working with a single digital input and a single digital output, you're working with just bits, okay? And so it's, the Arduino is very bit-oriented or byte-oriented if you want to write a whole byte of information. There are also some communication functions. So there's the shift in and the shift out. And these can be used with any of the Arduino pins. Then there's also what's called the serial command, and these work with specific pins. So they're fixed pins. And so we have a number of serial commands. So the command basically is serial dot one of these things. Okay, and so these functions basically allow various communication things to take place. So this first one here is not actually a function, it is a function, but it's checking to see if the serial port is ready to go. Okay, so if the serial function is ready, this will be a 1. If it's not ready, it will be a 0. So if you turn on, so for example, you would start with begin. That's similar to available. So if you start with begin, so serial.begin, it may take a little while before you can actually start, doing the communication. So a number of functions that can be used for working with serial. Some of these are pretty straightforward, like print. So print allows you to actually send data out the serial port. So write, so print allows you to send out like a whole string of information. Write allows you to send out a single byte of information. And similarly with read, we have something like that. I can do read bytes, and so a number of functions. I can set a timer to time out if it's taking too long, for example, for someone to if it's expecting input, like you want to enter in some values and it's taking too long, you can time out things. And so a number of things that can be done with the serial command. It's a pretty rich, this is a pretty rich set of communication commands, and it works with what's called a TWI, two-wire interface, to be able to communicate. So two-wire interface is actually the same thing that's used to program the Arduino, so that comes through the USB port. And there are certain bits that are actually assigned, digital input-output pins that are assigned for that. Now, like C or any other programming language, there are basic operators that can be used to do various things. So we have arithmetic operators, equals, which, A equals B, that's pretty obvious. Add, subtract, multiply, and divide, and also modulus. What is modulus again? That's right, you got it. Modulus is the integer portion of a number. So if you, for example, if you have, it's the integer portion of a quotient. So if you have, for example, the number pi, and you do pi modulo 3, then you'll get 1.141. That will be the modulo for that number. Okay, so if you think in terms of whenever you have a quotient, you have the quotient. Whenever you have division, you have the quotient and the remainder. Okay, so when you do divide, it's going to return a floating point number, which includes both the quotient and the remainder. Okay, so the quotient is the integer portion, the remainder is the fractional portion that's left over. So modulo just gives you the fractional portion of that quotient. Okay, comparison. So if I want to, in a test, I want to compare, is A equal to B? Well, I can't just use this equal, I have to use the equal to do this. So this is comparing two things, and that's what that means. Here's not equal. Okay, this is less than that, this is greater than that, so less than or equal to, greater than or equal to. Okay, I can have logical pointer, or I'm sorry, logical values. So if I want to compare, if I want to take the logical AND of A and B, I would use this. Here's the logical OR, here's the logical NOT. Okay, so again, also we have pointers that can be used. So we have the two different kind of pointers. This is just like in C. We can work with pointers in the Arduino IDE. We can do bitwise operations. So if I have A and B, this is actually a bit-by-bit operation. So I would take the individual bits of the two things and I would AND them together. Okay, so this one here is, I take the individual bits and I OR them together. Okay, and so this is the exclusive OR. And here, this one allows us to shift bits left and right, and so forth. I can also have some assignment values. So this does an increment, this does a decrement. This will allow you to, if I have A plus equals 3, that means that's the same as saying A is equal to A plus 3. But I can say A plus equals 3 and it's the same thing. Or minus equals, so it's A minus whatever. I can do times equals, divide equals, and equals, or equals. I can do all of those kinds of assignment things. Again, similar to what we have in C. These are the predefined math functions that are available in the Arduino IDE. So obviously there are many functions that are missing. Okay, so we have a very limited set of functions. So for example, arctangent, arccosine, hyperbolic cosine, a lot of things are not here. Exponential, EXP, standard function, not here. Okay, but what we do have, minimum, maximum, absolute value, sine, cosine, tangent, so we do have some trig functions. The two functions that I have here, constrain and map, are very similar to one another in that they are often used for input-output of data. But they're definitely different functions. So the map function allows you to do basically what's called a linear transformation. That is, it takes something, let's say something in this range, and converts it to something in this range. So I have two different ranges. The bottoms basically line up and the tops line up. So if I have a number somewhere like halfway between this in this range, it will end up being a number halfway in this range, and so forth. So you have that linear transformation. That's what the command map does. So you give it a number, and the number is in this range, and so you give it the minimum and the maximum value, and then you give it the minimum and maximum value of the output range. Okay, and so if the value that you give, the x value you give, is the minimum value in this range, then the output value you'll get will be the minimum in this range. If the x value you choose is the maximum in this range, it will give you the maximum in that range, so forth. Okay, so it's a mapping from one range to another range. So that's what the map function does. The constrain function is completely different. Basically, it says I have a number that I want to be in this range. I want to constrain it to be within this range. So if I have a number that's over here, if the number I received is like outside the range, basically what it'll do is it'll shift that number over so that it's in the range. Or if I have a number over here, it'll shift it over so it's in the range. So it'll line up with the range. If it's in the range already, then it'll just leave it as it is. But if it's outside the range, it'll either bring it up, if it's on one side, it'll bring it up to that side. If it's on the other side, it'll bring it up to that boundary. So whatever comes out of that function constrain is in the range that you specify for it. Okay, so that's what that is. It's not like map at all. It basically constrains the value to be within that range. Okay, so there's a square root function, there's a power function. So if I want to raise, let's say I want to take the cube of a number, I can use the power function. If I want to take the cube root of a number, I would basically use the power with a fraction. So I would raise something to the 1/3 power. And so anyway, the power function can be used to take powers or roots. Random basically returns a random number, but like any random generator, if you have a random number, it's not truly random. That is, there's a process by which that number is arrived at, and so that process, there's actually a pre-specified process. If you always start with the same seed, if you start with the same seed for the random number, you will always get the same random sequence. So in other words, if I take a random number and the next random number and the next one, they seem to be unrelated from one another. But if you start with the same seed, the first random number will always be the same. The second random number will always be the same, and so forth. So it's not truly random, and so you can change the randomization by changing the seed. Okay, so micros, milli, delay, these are all timing functions that can be used. So again, this is different than a lot of standard C type functions because standard C doesn't concern itself with timing. So there are built-in timers to the Arduino, and so these commands work with those. So delay basically delays in milliseconds, delay microseconds delays in microseconds. So you can have variable lengths of delays. So those are the important built-in functions to the Arduino IDE. In the Arduino IDE, we also have flow control, just like in C. So all the same kinds of things you would expect to see: if else, for loops. You can do switch case, which I always found pretty confusing. While loops, do while loops. You can break in the middle of a loop. You can continue, or you can return. This is used for a function. And go to. I can define a label, and I can go to that, which is supposedly really bad for programming in terms of programming, but it's available. So there are some things. There's sometimes when a go to is the only way you can get there from here. So, but these are your standard flow control from C. So a background in C is very, very helpful in knowing how to use these functions. Okay, so we basically have covered all the standard functions that are available in the Arduino IDE. That's it. That's all you get. So unlike C, where you can have malloc and all these other kinds of things, you can still use those kinds of things, but they're not a standard part of the Arduino IDE. You actually have to write a separate C program to work with that. And so with that C program, then you need to do all the includes, include all the different .h functions, .h files and so forth, header files. So now, as I mentioned, we can program both in the Arduino and in C or C++. And so what I want to talk about now is how do the two compare if we do one versus the other. So one of the biggest things that you find out with the Arduino is that the Arduino IDE is very simple to program. It's very nice. Functions are very compact and and readable, understandable. It's fairly straightforward to follow an Arduino program. Not so much with C. Okay, so here's a standard program which basically flashes an LED as fast as possible. So here, let's go through this program. So here's the setup program. The only thing in the setup program is pin mode. We're setting up pin 13 as an output. Now pin 13 on an Arduino Uno has an LED attached and a pull-up resistor already. So it's all ready to go. You can flash that pin 13 LED using built-in. You don't have to add any extra hardware. It's already got that LED that you can flash. So this is the setup command. And all we're doing is setting up pin 13 to be an output pin. So our loop command basically does a digital write. It sets pin 13 high, then immediately it sets pin 13 low, and then it just loops. Okay, then it just loops. So that is the fastest way to flash an LED using the Arduino IDE. It's this command. Okay, so for using C or C++, it turns out we can actually embed C commands directly into the Arduino. Okay, and so notice that here's our Arduino program. So our setup command is exactly the same. We could do this in C, but it turns out that this is not time critical. So once the thing gets started, this is not time critical. So it's easier to program just using the Arduino IDE. Now I also have a void loop, just like before, and now we have these commands, and we're going to learn more about this kind of programming later. So port B OR equals, so we're going to OR it with the hex number 20, which is basically what? 0, 0, 1, 0, 0, 0, 0. Right, so it's going to OR it with that. And what that does is that turns pin 13 on. Here we have port B and equals not. So notice it's and equals not. So basically this is going to be all ones and a 0 in that place. So we're ANDing something with a 0. That's going to make it 0. So this is going to turn pin 13 on. So basically what this does is this tells us that pin number 1, 2, 3, 4, 6. Pin number 6 on port B is connected to pin 13 on the digital input output. And so all this is doing is it's turning it on, turning it off, and then it's going back and doing the same thing. Now notice here I actually have two loops, a while loop, and this says while 1, which means basically it's always going to run. And then we have this outer loop that runs. So why would we have an inner loop that just loops when we already have an outer loop that loops? So these are some interesting things that you get when you're programming real-time systems, is that sometimes it's actually more efficient to do things one way versus another. What you find is that this while loop is fast, quite a bit faster than this void loop. So here, notice we're turning this on, turning it off right away, and then we're looping. If you ignored this while loop and didn't do it, the function would still turn on and turn off, but what would happen is you would not get a nice duty cycle. It would be on for a very short period of the duty cycle, and then it would be off for more of the time because it takes longer for that loop function to execute than it does for the while loop to execute. So this is one of those programming tricks that you learn mostly by trial and error or someone else's trial and error. It's a timing thing, and there are lots of interesting tricks that you learn when you're actually doing stuff that involves timing. So this is the fastest way to do the flashing of an LED in the Arduino IDE. This is the fastest way to do it using C. So it turns out there's no faster way of flashing that LED than using this little loop, this little while loop. There's no faster way. So how do they compare time-wise? Well, here are the results. So basically, if we use this, we will get a square wave that has frequency of 121 kilohertz. That's the frequency of the on-off that we get here, 121 kilohertz, which is pretty fast. 121 kilohertz, a lot faster than you can see it. Okay. Over here, when we work with this function, this gives us a frequency of 2.66 megahertz. So that's quite a bit faster than this. So it's more than 10 times faster. It's probably about 20 times faster. Yeah, it's about 20 times faster than this. Okay, so just by changing things just a little bit, we can increase the speed. So if speed is critical to you, then it's obviously going to be more important to use the C or C++ than it is to use the Arduino. So so in terms of speed, in terms of ease of writing, this is the easiest way to write things. So this is definitely more complex. You have to understand where all the bits are, how to turn them on and off, and so forth. But we can definitely get better speed using C or C++. So, and we're going to find that we can get even faster if we use the assembly language. I'm not going to show you the assembly language yet. It's even more complicated. But this is how we would do flashing an LED. Here are some other benchmarks. I'm not going to go through these all, but this kind of gives you an idea of how long each of these commands takes to execute. So you can see that this one takes 3.73 microseconds. So to read something takes 3.7 microseconds. To write something takes 3.9. So it takes a little longer to write than it does to read. To set up pin mode takes 4.6 microseconds. To do a multiplication using a volatile byte data, we get that. It takes that long. If we do a divide using volatile byte data, it takes a lot longer. So that's very common. It takes a lot more effort to do a division than it does to do a multiplication. So notice we have a longer thing here. Okay. If I want to get a random number, it takes 137 microseconds. So quite a bit of time for it to figure out how to get a random number. Divide with a double float takes about 80 microseconds. So quite a bit of time if you want to do a floating point variable. So here we say a double float. It's really just a float. Because I don't know why it has single float and double float, because in Arduino single, oh I know, well actually I don't know. Anyway, these are some benchmarks for all those things. Analog read takes 112 microseconds, where an analog write takes 11 microseconds. So again, big difference there between reading and writing. So what about delay? So we have a delay function. So 1 means 1 microsecond, and it takes 1 millisecond. 1 millisecond. So notice it's pretty close to 1 millisecond. 100 milliseconds. Notice it's pretty close to 100. It's like it's off a little bit, but it's pretty close. Delay microseconds. So this should be 1 microsecond, but it's not. It's a little less than 1 microsecond. So it's not that accurate. Delay microseconds, 5 microseconds. So you can see it's off. 100 microseconds, it's getting a lot closer to being correct. So it's just that if you try to delay for a very, very short amount of time, it's not that accurate. But if you do it for longer, the accuracy increases. Okay, here's a program that can be used to do serial communication. This is an example program. And so notice in this particular program, I have a setup command and a loop command. Notice there's nothing in the loop command. I only have stuff in the setup command, which means basically this program goes through and does this stuff once, and then it just sits there and does nothing. Okay, so this kind of thing is very common if you just want to run through something once. And so notice that with the serial print command, I have the thing serial, which basically tells you whether the serial port is ready or not. And I have serial print, and notice I can I can give it data. In this case, our data is some number. And I can print it either in binary, octal, decimal, or hexadecimal. And I can also use the serial write command, which is different. And then the serial print with the line feed. So basically, this will give you a carriage. So if you don't do notice that in a serial print, you can actually use formatted text, like we format with C programming. So all of the escape sequences you can use. But if you don't put in an escape sequence that gives you a new line, then this will give you a new line. Okay, so that's the serial communication. So this gives you some idea of how to use the serial So there was a page back there where we had all of the serial communication commands. So this shows you how to use. It gives an example of how to use that serial communication stuff. Now, the Arduino, in terms of serial communication, we have two things that are really critical numbers for us in terms of the serial communication. One is latency. That is, how long does it take for the data to get across? Okay, so how long does it take for the data to get across? And so notice that as a function of message size, so that is, if we send a longer message, you expect it to take longer to get through. Okay, and so notice that for some, this is very much like a stair-step type of function. So latency is in milliseconds. So notice that even for very small messages, it takes at least something milliseconds to send that thing. But if we send it up to about 40 bytes, we basically get the same. It takes just as long. In other words, it doesn't take much longer to send 1 byte as it does to send 40 bytes, which is kind of interesting. It's like it has to build up and then it bursts. And then if you want to go from 40 bytes to 50 bytes, notice that there's again another delay, and so you have these delays. It's like it jumps. So it's, basically it takes about the same amount to send something at about 75 bytes as it does about 50 bytes. So we have those kinds of things that happen in terms of latency. How long does it take for a message to get through? And so again, the longer your message is, the longer it takes to get through. But it's not a continuous function. You would think that it would take very little time to send a message of 1 byte. So again, this is serial data. We're sending it serially. You'd think it would take, 1 byte would go quickly. So remember, when it sends it serially, it sends it bit by bit. Okay, but for the Arduino, it takes at least 4 milliseconds to send anything. Okay, and so once that's the case, it's somewhat linear, but it goes in this stair-step fashion. So that's if you're concerned about the timing associated with communicating serially, this is the kind of situation. So basically, I didn't generate this plot, but whoever did basically did a number of runs. Okay, so it chose a message of size 0, 1, 2, 3, all the way up to 250. Okay, bytes, and they did it several times. So basically, these were 4 runs, more than 250 runs, 250 messages. So there's more than 1,000 messages were sent in generating this plot. Is basically what this comes down to. Here's a similar plot. So this is the rate of data transfer in kilobits per second. So this is kind of like the inverse relationship that we get. And so again, versus message size, this is what we get. So notice that for small messages, we have very small bandwidth. Okay, very small bandwidth, very low band. So that was a consequence of the fact that even with just one message, with 1 byte, it took 4 milliseconds. Okay, so that means this is like 0.24 down here, so it's pretty small. So this is kilobits per second. How many kilobits per second? So almost none. Okay, and so notice that that this rises linearly because remember it was roughly constant, and so anyway, this is basically like an inverse relationship. How much data got out, how many kilobits got out in that number of seconds. So so this is the bandwidth, and again, it's related to the latency of the communication. So these show how the serial communication works, and again, we have a number of serial communication commands that we can use, and those serial communication commands are very helpful to be able to transfer data back and forth. So this now is the overview of the Arduino. We have looked at all the basic functions and commands of the Arduino. Thanks for watching.